Hi there. This video is going to go over how to do work problems, and I think the best way to demonstrate that would be to work on some problems and explain the process as we go. So let's look at this first problem. It says a water tank can be filled by pump A in 8 hours. Pump B can fill the tank in 24 hours. How long would it take them to do it together? Well, as you remember from other word problems, the first thing we always do for a word problem is write down what we're trying to find. And in this case, what we're trying to find is how long it would take them to do the job together, to fill the tank together. So number one, we write find the number of hours working together. Step two is the one that changes depending on the type of word problem we're doing. So for work problems, this is what step two looks like. We write fraction plus fraction equals 1. The reason we write a 1 there is because the 1 stands for one job. In this case, the job is to fill the tank. On the bottom of each fraction, we write how long it would take each of the pumps to do the job alone. So the first thing we should probably do is label these. This is going to stand for pump A. This one will stand for pump B. So on the bottom, I'm going to write down how long it would take each to do the job alone. Okay, you can see that I have put an 8 under the fraction for pump A and 24 for pump B. And over here, the number of hours to do the job alone is what goes on the bottom, and on the top, we put the number of hours worked. So if you look at this problem, you need to ask the question, were they both working for the same amount of time? And the answer is yes, but I don't know what that time is, and so that's my variable. I'm going to put an x here, and I'm going to put an x here. This is your equation. So for step 3, normally our equation happens on step 3, but since this is going to usually be a rational equation, what we're going to do for step 3 is write down what the LCM is and if there's any restriction on our variable. Now for this one, the LCM for 8 and 24 is 24. So my next step would be to actually solve this equation. I'm going to multiply all the way through by my LCM to clear the fractions. When we multiply through by the LCM, please make sure you multiply both sides. A lot of times students forget to put the 24 on the right side. On the left side, I'm going to cancel, and here the 24's cancel, and what I'm left with is 3x plus 1x equals 24. That's a very simple equation to solve. I've got 4x equals 24, and if I divide both sides by 4, I end up with x equals 6. So circle that. That is our step 4. And then go back up here and remember what that x represented. It represented the number of hours that they both worked. So our step 5, as is normally the case, we're going to write a sentence with our conclusion. Therefore, the pumps will fill the tank in 6 hours. So the main part that you really have to be careful on is this step 2. It takes a boy 15 days longer to pick a certain orchard than a man. If they can do it together in 4 days, how long would it take each alone? So our first job is to write step 1, what we're trying to find. Find the number of days for each working alone. Now for step 2, as we did before, we're going to set up a fraction for each of the people involved. Then the one job that they're doing is this picking the orchard. So I'm going to have a boy and I'm going to have a man. So I'm going to label those. On the bottom of the fraction, I put how long it would take them each working alone. Well, I don't know that. So that's where my variables are going to come in. But if you look at this, it says it takes the boy 15 days longer than it does the man. So if it takes the man x days, then it's going to take the boy x plus 15 days. Now if you look at the top, that's where we put how long it would take them each working together, or actually just working, and it looks like they're going to work together for 4 days. So they're both working the same amount of time, and it's 4 days. So that means I put a 4 here, and I put a 4 there. So remember what goes on each parts of the fraction. In the denominator, we put the number of hours to do the job alone, and in the numerator, we put the number of hours worked. And it always equals one job. So now this one's a little different than the last one because my denominators are not integers, they're actually polynomials. So for my LCM, remember that when we have LCMs for rational equations, both of these denominators must show up in the denominator. I must have an x as a standalone factor, and I must have an x plus 15 as a standalone factor. And if that's the case, remember that denominators can never equal 0, so I need to state my restriction saying that x cannot be 0 or negative 15. If x is negative 15, this fraction is undefined. If x is 0, this fraction will be undefined. So now we need to solve the equation. Once you write the LCM all the way through both sides, then you can cancel. The x plus 15s cancel, the x's cancel, and what I'm left with is 4x plus 4 times the quantity x plus 15 equals x times the quantity x plus 15. When you clear the parentheses and look what you have, you notice you've got a quadratic. Whenever you have a quadratic equation, get everything on one side and then see if you can factor. This one factors pretty easily. So my solution is x equals negative 12 or x equals 5. Now, remember what x represents. It represents the number of hours, or in this case days, to do the job alone. It's impossible to get a time that's negative. So we're going to cross that one out. We'll circle this one as being our step 4. And then besides needing x, which was the amount of time that the man works alone, I also need x plus 15. So write x plus 15, 5 plus 15, that's 20. So you also have another answer to circle. And then it's just a matter of writing our conclusion. Therefore, it would take the man 5 days to pick the orchard alone, and the boy 20 days working alone. Okay, here's the next problem. Pipe A can fill a tank in 6 hours, and pipe B can empty the tank in 20 hours. If both pipes are open, how long will it take to fill the tank? This is a little bit different because you have two things here, but they're actually working against each other. So first of all, you have to determine what the job is. For this problem, the job is filling the tank, not emptying the tank. So it looks like pipe B is working against the job. So what we do is we still do fraction, and it equals one job, but in this case, the job is filling the tank. So I'm going to have a positive fraction for A, but I'm going to subtract the work that B does because he is working to undo my job. Okay, let's fill in our fraction. All right, on the bottom of the fraction, we put the number of hours to do the job alone. A can do the job in 6 hours. B can do its job in 20 hours. Now, I know that this is emptying instead of filling it, but that's where this sign comes from. We're subtracting that job. On the top, we're going to put the number of hours they work together. It says they're both open, and they're both open for the same amount of time, so I'm going to have the same variable on the top of both of these fractions. For my step 3, I need my LCM, and the smallest number that 6 and 20 will go into is 60. There's no restriction because there are no variables down here, so I can solve my equation. When we multiply through by 60 and do our canceling, we end up with 7x equals 60, divide by 7, and x equals 8 and 4/7. So then I just write my conclusion. The tank will be full in 8 and 4/7 hours. Okay, here's the last problem. A man was laying a brick wall, and after working alone for 2 days, he hired someone to help. Together they finished the job in 4.8 days. The assistant working alone would have taken 5 days more than the man. So find out how long it would take each to do the job alone. So I've got it set up here. Step 1, find the number of days for each alone. And I've got my fraction ready to go, and I just need to fill it in. Now, it says we're trying to find how long it would take each to do the job alone. I've got the man, and I've got the assistant. I know that it would take the assistant 5 days more than it would take the man. So if it takes the man X days, the assistant would take X plus 5 days. So I've got my denominators in. Now, as far as the time on the top, for this problem, the man is working for 2 days alone, and then he's working for 4.8 days with this other guy. So altogether, he's working 6.8 days. The assistant is just working 4.8. It's not unusual for you to have different amounts of time here. Unless they start and stop at the same time, you'll have different numbers here. So that's always something to ask. Okay, so now I need to find my LCM for step 3. My LCM is going to be X times the quantity X plus 5. And from that, I can tell that X cannot be 0 or negative 5. So let's solve the equation. So we clear our fractions here by multiplying through by the LCM, do our canceling, and this is what's left. After doing the distributive to clear the parentheses, I'm left with this. Now before I go any further, I see that I have decimal numbers, so to clear the decimals, I'm going to multiply all the way through by 10 because that will move the decimal point over one place to the right. I'm also going to put all of the terms on one side of the equation because I'm noticing I have a quadratic. So here I have my quadratic equation, and I notice that there's a factor of 2 in all 3 of those terms. So just to make those numbers a little bit easier to look at, I'm going to divide all the way through on both sides by 2. I factor my quadratic, set each factor equal to 0 and solve, and I get these two solutions. Now time in the context of this problem cannot be negative, so I'm left with x equals 10, and then I've got x plus 5. 10 plus 5 equals 15. So this would be my step 4, and then I would write my conclusion. It would take the man 10 days and the assistant 15 days working alone. So when we look at work problems, the important part is right here on this step 2. You know how to do all the others. This is the only new part. On the bottom of the fraction, you write down how long it takes them to do the job alone. In the numerator, you write down how long they're actually working. And in this case, this guy was actually working longer than this guy was because he started earlier. There you have it. Good luck.